I want to remind ourselves about linkage maps, and let's focus on meiosis 1. And specifically, let's focus on prophase 1, which is in meiosis 1. Yeah, my bad. So if we remind ourselves about this, you can remember that you have the mom chromosome copied, and then over here, let's say you had the dad chromosome, and it was copied. And let's say this was for position 1. What would be the relationship between these two little guys right there? Their sister what? Chromatids. And these two are little chromatids right here. Perfect. And what I want to show you is I want to show you the disconnection, or the swapping, if you will, of a piece from right about here to a piece over here. What's this called? Crossover. Perfect. So in the end of crossing over, what we should have, post-crossing over, is we should have a setup that looks something like this. Does that make sense? Now, originally, these sister chromatids right here were what in relation to each other? Identical. And these two are identical. So you would have, if you think about it, some identical guys there, some identical guys here. Now that's no longer the case, right? And you know that when you do this crossing over, you can expect that it's a pretty random crossover event. So it's random when the crossing over event is going to happen. Exactly where. Yeah, maybe not the when as much as it is the where. How much will be cut off? How much will be disconnected and then reconnected? We cool with this concept? There's really no questions about this. We're pretty much set. And so that's the other thing too. We always teach it like it's a little piece at the end. It could be in theory pieces along the way, and it could happen more than once. No, it can't be an entire swap, but it can be a tiny piece.
You can just do a sliver near the end, but then have to go all the way through there.
Awesome. Yeah, totally. You're going to just cut off those pieces. And again, it's random how that works out. Now, according to the concept of linkage maps, it would make sense, or it would be sensible, that there are some cases, or there's a time and place where things are connected. I guess they're connected very well together, you could say. So let's talk about that in terms of a linkage map. What if I had a certain gene right here? Actually, let me focus on the original cell. Let's say I had a gene right here, and then I had another gene right there. Are they fairly far apart on the same chromosome? That means that probably if you do this disconnect, like you're seeing crossing over, there's this unlikely event that these two genes are inherited in a combination because of the far apartness, right? So I think it would make sense that, and I'll show you a picture that Thomas Hunt Morgan had generated. Let me find it real quick. What Thomas Hunt Morgan had generated, or what he had discerned, was that if you were able to determine the number of recombinants over the number of normal cases, you could find this concept of recombination frequency. And he developed this linkage map, and it used map units. Yes, basically. Yes, absolutely. And so, I don't know if I like this picture as much as I like this picture right here. Let me show this to the current. Let's see this picture. Yeah, definitely some biology. Luis, could you not do that right now, please? You too? No. Because the way it works out is that this is the recombination frequency between these two genes, and that 9.5 is the recombination frequency between the CN and the VG, and the 17% is the recombination frequency between these two. Now these are percentages, right? You have to actually reproduce these little slides. That's what he was studying to see this data. So these stats are not going to match up. Now you can agree that 18.5 that you're getting, Sam, is closer to the 17% that you're seeing here. Agreed? But it's not exact, and that's because you're talking about just numbers that are not infinite. Your sample size is not forever. Right? Now, this is recombination frequency. This is like the chance that you make like if you will, a unique mix, right? It would make sense that this big B and this like CN gene are inherited as a combination, right? So I would say they're recombination frequency. They're mix-up frequency. When someone says the word recombination to me, I think of the word recombination as basically being like the tendency to mix things up. That's like what goes through my head. So the mix-up frequency of this is basically like 9%, which means these two are going to get inherited as a combination. Exactly. There's a 9% chance that there would be a disconnect because there's very little space between them. Now, between B and VG, there's like a 17% space of separation. That means that there's not as much of a likelihood that the B and the VG, are y'all watching this? Are y'all with me on this? There's a 17% chance that the B and the VG will not be inherited together because of their location. So that means that when they're very far apart, when you have two traits that are extremely far apart, like maybe one that's right here, y'all watching, and one that's right over here, it's unlikely that they will be inherited as a combination together. A recombination, which goes exactly above. And the deal is that once you get to 50%, that's like your maximum, right? Because it's just that goes back to like the Mendelian principle of independent assortment. Once you get to 50%, you approach what's called Mendelian like independent assortment, which means that there was a 50% chance they were going to separate anyway, according to Mendel's movement of these chromosomes, of these genes. What? So once they're very far apart, it's irrelevant. They were going to separate out anyway. Question? Back in the back. Caleb, was that you? Good job. Yay? So linkage maps. So honestly, you know, if you're looking for if this is a little bit above your head and you're like, I don't really get what the guy's saying right now, take them. Then here's the way you're going to do it. If I gave you B to VG, and I said that number was like 40%, and if I told you that B to C was 20%, and if I told you that, and this is very hard for you to do, so like, forgive me on this, but C to VG was 30%, and this is, again, I'm making this up, so this will not go smoothly, I can already tell. But I will put B and VG at opposing ends because they have the largest degree of separation. B and C are pretty close with a 20, so I'm going to put maybe them about right there. And C and VG are about 30. That could work. Now, this goes back to Sam's point about why is this 20 and this is 30, which adds up to, what, 50? But then this total right here is 40. Again, it's just the stats of it. Or in my case, poor problem creating. But do you understand how you would do this? Y'all remember doing this type of a question. If you make this happen, there's a point for you on the AP exam. So must have. Good. What was the other topic? I have a short-term memory problem. I think gaseous tissues. Endoderm, mesoderm, ectoderm, or plant. So maybe that chapter real quick. So let's go ahead and turn to our notes. And if you have the phylum sheets printed out handy, you might want to get that out. Okay. 41. I do. What?
I'm not going to tell them. Maybe keep it.
I'm actually going to delete the website if you need to show.
Really?
It was a bad idea.
I mean, look how much little work that you do here that like next year to maintain it. All you have to do is like maybe update the calendar. Everything else is already there.
No. Chapter 31. No. Chapter 30. Hold on, let me think. 32. Chapter 32 is where it's at.
The framework for success is already in place. Oh, I want to get like 6 at the day. Grab on day. Bounce the conversation with like somebody.
We're going to go over animal tissue. We good? Again, all the reason to go over it, it sounds like to me. So chapter 31, right? Oh, 32, my bad. I keep saying 31. I meant to say 32. Now, seriously, this is a great chapter to read. If I was to say to read like some of these chapters, And if I was to pinpoint out like maybe 5 or 6, okay, chapter 32. I would say definitely you want to be looking at this chapter. This is one I would suggest that you read along the way, just me personally. So, let's go ahead and remind ourselves, this is the big point to make. You start out with a zygote, and you go from being a one-celled zygote to having an 8-cell stage, little creature. So it's kind of like a circle, but there's 8 cells there. It's 3-dimensional, obviously, in a horrible drawing. 8-cell stage. And then you start to undergo successive rounds of mitosis without increasing overall size of the entire group of cells. So you just have a many number of cells, and that event's called cleavage. And after that, you end up with a hollow ball of cells. Perfect. So again, my drawings are horrible. If you don't like it, whatever. There's the blastula, which is going to be your hollow ball of cells. Now, then the blastula starts to cave in a way. Now, on the very inside of your blastula is something called the blastocell. It honestly could be, it's going to be like a factor of 2, like a exponential factor of 2. But I couldn't tell you. Probably 128, maybe 54. Brad, your question is going to be these are all stem cells at this point. Now you're going to start to undergo this process called gastrulation. So once you go through the process of gastrulation, you end up with a system that's like this. Now I know that this is strong and extremely poor. Again, I think Joseph failed it. But I imagine, when I'm thinking about how to display this or draw this nice or effectively, what's going on through my head is this idea that you have this basketball that you've blown up. I don't know how to say this nicely. You have a basketball, it's not caved in, but it's not full of air either. Does that make sense? And then when you start to push it in, it caves, right? This push in is the gastrulation part, where it starts to cave inward. Does that make sense? Now, as this continues to happen, imagine that you end up with a case that's something like this. After you go through more gastrulation. Gastrulation here as well. You end up with this unique structure that's having more than one tissue layer. You've got your ectoderm, you have your endoderm, and right here would be some mesoderm right in the middle. Now your book, and again, I am not using color on this, and I'm going very quickly. Your book has a fabulous picture with blues and yellows, I'm pretty sure, maybe some oranges on it too. That helps you see the different layers of tissue that's created. Does anyone have their book open? Does anyone have their book here? This chapter 32, this is going to be on the, I believe, left-hand portion towards the bottom, if I'm correct. See. No, I'm thinking go back a little bit. Perfect. Right-hand portion. Not bad. Yeah, what page is that? 635. So page 635. Definitely want to, I think, know that. Awesome. Now at the end, you have this object that's called the gastrula. And yeah, I think it's pretty simple. Now another thing that you talk about in this chapter 32, is you guys talk about the idea of bilateral versus radial symmetry. But I think y'all should remember this, correct? This calculator has what type of symmetry? Actually none, because the buttons are different on both sides. What? What about me? What type of symmetry do I have? Right down the mid-size of the line. What's that mean?
You gotta give it to him.
That's what that means? Less or more?
You make a good point and you're okay.
A sponge. What's that? Probably radio. Stop. Completely fake show. How about a Nidarian? Radio.
sea.
Jellyfish, dude. Jellyfish.
Cnidarian.
Cells of the sea. How about an echinoderm? What's an echinoderm? Starfish. Starfish. That's going to be radial. Y'all remember this stuff, right?
Yeah.
Remember I taught this, right? Y'all took the pictures, right? This kid had his hand in the stuff. Y'all remember this?
He started laughing during the quiz.
I had to sit down during the quiz.
And he drew a mustache on you on your picture.
Now, Ian, if you'll turn, I'm sorry, on page probably like 637, like two pages later, it's going to be this next picture. Is that it? No, this one. All right, guys, let's do this. I'm sorry, what? 638. I was close.
What are we doing?
Probably want to copy down these three shapes here.
What is the whole like gastro?
Isn't that from the anus?
I'm not going to make a joke.
That opening becomes either the anus or it becomes the mouth. Depending on what type of creature it is. For a deuterostome, it becomes the anus. For a protostome, it becomes the mouth.
And we're doing
So the anus comes from the
A deuteroderm, but it is one and the same.
What?
Some organisms. Can you just go back to sleep?
These are like taking a phone call every morning.
Hey.
French. Okay. Now, your question was like, why did we leave just that little page we were on, and why do we talk about this now, and why do we leave like this gastro the way that it was? That's because like once you have that hollow ball of cells infold in, you have your tissue layers formed, and that's it. From that point onward, you have like growth of those cells. Those 128 cells that you had called out, or maybe 66 or 64, I don't know, however many there are at that stage when that happens. But those cells start to multiply, and the baby gets larger, and you start out as that ball, and those cells at the different points start to differentiate. And that's how you're able to create an organ one fish or the other. So that ball just starts to grow into a larger looking ball that's just like that. And so the cells become differentiated. There's a special area that is like that is maintained by the first when you have the 256 cells that are in that zone, they are all stem cells, but that's a very small structure. It's not until that structure is very large and that ball, if you will, that gastrulated ball, is large enough that you can pull it out and use it for stem cells. That's the old school type of stem cell research that we used to do. And by that point, some of the cells will become differentiated, so you just have to like syringe in or needle in or grab certain cells that work inside just the gastro part. Yeah. So the difference between like the statement of the cells of that picture that we just copied down not being like them all being stem cells, they are, but you can't really use them because can you see one cell? No. So how about the 200 cells? Do you see that? Not really. It would be less than a speck. Something you certainly couldn't like grab like with a syringe or something. What? The stem cell research that they did back in the day that's now illegal would have been to wait longer for that structure that we've just defined to grow up into this little ball of those cells, start to differentiate a little bit, then grab the cells that are right on the inside that are still left to differentiate.
That's where you run into more with
Wow, dude. So on this one, you see the difference between a coelomate, pseudocoelomate, and coelomate in general. Notice that the coelom is like this cavity that is in between different tissues. It's the white space right here. If you understand that this tissue is white space, that is the coelom. Now notice that there's different ways this can occur. Notice in your top page is the coelomate. What do you see about that type of tissue? What is it lined with exclusively in that top drawing? Lined with what type of tissue? Lined with mesosome. Right? So if you're a coelomate, urocelomate. You have a complete digestive tract. That means you have the internal cavity that is lined with both mesoderm on both the in and the outer portion. In other words, you look at like that, like if you open up the inside, like right here on your stomach, and you feel on the, right on the tissue that would be one through your skin. That would be mesoderm. You feel the small intestine. Feel on the outside, that's mesoderm. You understand? Now in a pseudocoelomate, do you still have that cavity? Do you still see white space in the pseudocoelomate? Yes, Mr. Fields. I can see the white color with it. But is it completely lined with mesoderm? No. So the inner part is not lined. So that's why it's a pseudocoelomate. It's not completely lined with mesoderm. So this pseudocoelomate versus acoelomate thing isn't a cavity being there or not. It's what's the lining of the cavity is the difference.
What's the advantage of having extra lining?
Basically, yes. I don't get it. So what?
What's the advantage of having extra lining? Around the air. No, I know what it is, but I don't know, like, what's the advantage of it?
I don't think it's necessarily like, I'm sure there's some advantage I can identify, it's just a trend in evolution. More so than anything else that I could be aware of. Then here, you have like the acoelomate, which you can see, essentially there's no fluid cavity at all, right? It's just lining of tissue. Now, an example of an acoelomate is this guy. What phylum is he from? The pseudocoelomate, that's the roundworm. Do you remember the phylum? Phylum is the flatworm, dude. Nematode, guys. Nematode is the phylum. What's the phylum up at the very top? It's the coelomate. The annelids, the segmented worm. And beyond that point of annelids and beyond, they're always coelomate. So are you a coelomate? Yeah. Yes, because you're more evolved than the annelids. You see these cutoff points? Like going from bottom to top, those three different groups, go from left to most evolved. Just bottom. That's the perfect cutoff. Question. All of our it's all lined with everything. What? I couldn't honestly. I could not say because they're all derived from the same stuff. I think we're talking about deuterostome and protostome. I guess that would be all of 32 you really need to kind of look at. Now I have that little phylum sheet up on the website. That's perfect for 32. I'm encouraging you strongly to read that.
So, like, on the AP type, how many
Yeah. So.
How many classifications, like, what's the depth of classification off in those AP?
As much as you need for this class.
Like, how many questions would be asked? Like, did you kind of, like, show pictures?
Yeah, they would show pictures of that little worm. It was a flat worm. The flat worm next to the main phylum. Yeah, absolutely.
Or that time. I mean,
it's not a college class or anything.
Yeah, they kind of is. Like you have to be able to look. You have to be able to look at a plant and realize like what type it would be.
Very good.
Good job, man. Versus what? Like if they had a picture of a little plant growing on top of another plant, what plant would that be? That would be a bryophyte. That would be a moss. What would be a stone plant? What plant would that be? Stone plant.
What plant?
Bryophyte.
You all need to study, dude. What if it had a flower? Yeah, I did. Well, so random facts, like how about this one? Chordates are deuterostomes. Name another deuterostome. Chordata would include hundreds. Perfect. That's a good answer. Starfish group. Species number. What group is that in?
What do you know about this?
What? What? A weapon?
Can we go over a meeting?
Right now?
Yeah, I don't want to.
Got it.
Got me? You want me to put it back on?
Okay. It's been a lot of fun.
I have to go to my car to get my Camborne read too.
Okay.
Actually, you can't. I have to go to a town meeting.
No, dude, you don't need to. No, dude.
If I have lunch, I want to go get my Camborne read for my car. It's a true story. Because I'm taking the test today.
The immune system. First off, let's talk about two very broad types of immune systems. Let's talk about an innate immune system, so innate immunity, as opposed to an acquired immunity. So about innate immunity. These are very non-specific responses. Typically skin-based, mucus-based. Can include macrophages or any other phagocytic type of cell. This is opposed to an acquired immune system, which is that's like the Booyah system. You could agree that this is like lines 1 and 2 of defense. This would be like line 3 of defense, a very specific immune system. And typically this has a response that occurs post-infection. So the nasty is already probably inside a cell, if not many cells, by the time this system is activated. Oh, it just means 1 and 2 aren't all-encompassing. They're not a guarantee. Right?
Yeah.
Okay. Let's talk about what a lymphocyte is. What's a lymphocyte? Be more specific. I would say your B's and T's, right? And when we think of lymphocytes forming maybe two systems, I think of like a humoral system that exists because of this, and then I would say a cell-mediated system. When you drop the term humoral, what type of cell are we thinking about, B or T? B. And are we thinking about antibodies or NK cells? I think we're thinking more antibodies. As opposed to cell-mediated response, which is going to be more of a, what? Maybe like a cell-mediated T-cell system? Cytotoxic T-cell, right? Recognizing that there's a cell that's bad, recognizing like a cell from non-self type of issue, out to destroy your cell's gone bad. Right? What? Really bad joke. Are we okay with like the first line of defense? So just start shooting words my direction of like first line of defense. Skin, lysozyme.
You got hair.
Lysozyme.
I'm talking.
Okay.
Good stuff.
Right?
Hair.
Hair.
Earwax.
Even earwax, surprisingly. Eyelashes. So I think we get this idea that it's anything very external. Now, give me the second level.
Quick question.
No.
Oh. Can I actually do this question?
Sure, go. No, do it.
What's the lysozyme?
Lysozyme? It's a chemical that disrupts the membranes or probably the walls of bacteria.
Isn't that something with
Could be in tears or in sweat. Saliva, I guess maybe a little bit too, but I know it's mostly tears and sweat. I would assume saliva, but I can't guarantee that. What? Okay. Still non-specific though, right? What else? Oh, we're doing phagocytes, I think here. Macrophages. I think that's pretty decent. Then your third line is going to be like the big one, right? I also want to like include in maybe the second line. What else would maybe I include in the second line? The complement system. Neutrophils are good. How about mast cells? Yes. What are mast cells producing? Come on, guys. What do you think this is? A joke? We went over this. Histamine. What does histamine do? Dilate or not? Vasodilate or dilate or constrict? Okay, histamine, which dilates, right? Does that thing like I have a bigger or smaller pipeline? Perfect. I like this. Is like kindergarten class, and y'all should keep this up. It makes me smile. Does that mean more or less stuff? More stuff. So if you have more stuff coming in this direction, then it would make sense that maybe you have more of these guys, so maybe you could like destroy the nasties a little bit more, right? This is like basically identifying that there's maybe this is like the CIA, right? Like the Central Intelligence Agency.
If that's a natural thing that's good, why do we stop that?
Because sometimes it balloons up to such a degree that there's like this inflammation of tissue, maybe even some pain or swelling. If they're natural, exactly. So sometimes that's the problem. Is that sometimes allergens, which are like not as negative, will cause these issues to exist, like this dilation to exist. You don't necessarily like need it, like right. So kind of in a way.
Okay, so they're like the CIA. The histamines are like Jack Ruby. Right.
You gotta be joking. Looking at your third line, who's the guy that's going to be responsible for starting the third line as a general approach? Helper T cells are all about starting up this process. Now they can start up both the cell-mediated, or they can start up a humoral response. Right? Now, when they start, when this process starts, up, if you will, what are the T cells recognizing? These helper T cells, they're recognizing. Yeah, they're recognizing like the MHC particle, right? They're recognizing like a non-self identifier, correct? Now these other guys over here, like in some of your humoral responses, they're recognizing like antigens, right? They're recognizing either like the cell-mediated process is recognizing that there's like an outside, I guess, writing that is not normal, the MHCs, or your humoral responses is recognizing like the antigens, right? They're recognizing like the particles that are brought in or created by the evildoers, right? Okay. What else about this, is something that I could go through, because I'm looking at my notes, of course, there's like tons of stuff. Y'all remember like, I guess, immunological memory, the formation of like B memory cells, right? The fact that these memory cells will help you create your response cells, or specifically the third line of defense very, very quickly, right? So you recreate it very quickly so that you're ready to respond to it. I think immunization and vaccination are totally fine, right? Me? I would say cell-mediated is definitely going to be viral. It almost has to be. Humoral is probably going to be for more bacterial-based. I might put anything that's probably living, like a non-virus particle, as being humoral response-based, like your humoral system takes care of it. And cell-mediated would be more viral. But I think that's a very, very general approach. That's not. I would suspect that's not even close to a guarantee. There's all types of memory cells. Your book doesn't even encompass like the total number there are. In general, I think in general you just have to know there's memory cells out there. It's just there's a certain type of system that's going to take care of that issue. So you would make extra cells that are memory types that are all about kind of remembering what the infection looked like, and you're kind of remembering a little bit of like what sequences of DNA had to be activated to kill the other cell. What pieces of protein did you need? Random. Now, I think the essay that if you ever got one in the AP exam, it would never be specific, like describe how the humoral response system works. I think it would be you identifying like some couple of different pieces, this piece, and then part C would be like, what's the value of having all these different pieces? And you would write something about how having all these different pieces would be advantageous is a guaranteed hit the issue.
Just general reason for the data.
Buy the next version, dude.